Hey, welcome everyone into the Wells Tech Garage for this month's training class for the 2 p.m. Central Time class. Today, guys, we are going to be finishing up talking about Toyota. We have a couple different systems I want to talk about today. We're going to talk about the system that is used on this 06 Avalon behind me here. We're also going to get into some hybrid systems, something that you guys might not see every day, but it's good to have that information out there. So why don't we jump right into it with the t-shirt giveaway question. Oh, and Jim, I'm glad I got your name right. Sometimes I just mess up usernames and people's names, so if I ever call you guys by the wrong name, I apologize, all right? It is hard to keep everybody's name straight in my head. Unless, like, your username is John, well, then that's pretty obvious. But, all right, so let's jump right into it, guys. The question is, now, actually, before we go there, I just want to say that the last question, I understand, was a pretty difficult one, and I didn't give you guys any multiple choice options. So this one, we've decided to be a little bit nicer, and we're going to give you guys some options to choose from, 4 options to choose from. All right, so here's the question. A Toyota intrusive style system. Now, guys, this is a kind of a review question to see if you were paying attention last week. And a Toyota intrusive style EVAP system is running through its monitor and testing itself for leaks. All conditions have been appropriately met, so don't answer back with any sort of answers like that are condition related. Everything is appropriately met, and this system is running and testing as it should. Upon starting the car, the test begins. The PCM opens the VSV for EVAP, which is the purge solenoid, but the fuel tank pressure sensor, or VPS, is showing an increase in pressure, not vacuum. What is the most likely cause? A faulty fuel tank pressure sensor, a restriction in the system, is this normal operation, or do we have a stuck closed VSV for EVAP? The purge solenoid, is it stuck closed? All right, email your answer to me. My email address is right here on the screen. Otherwise, down below in the description you'll find it. Otherwise, Dave will bring it up on the screen. And then, yeah, email me the answer. And if you're right, you'll win either one of these Wells Vehicle Electronic hats or your choice of a blue, gray, or wherever the black shirt ended up, t-shirt in whatever size you may wear. All right, so good luck. You have a 25% chance to win something. And if you don't know the answer, guess. You have a 1 in 4 shot. Couldn't get much better odds. All right. Let's get right into the system because I have a lot I want to talk about and a lot that I want to show you guys today, and I don't want to take too much of your time. So let's start with some overview. Then I'm going to go ahead and I'm going to bump into actually demoing some of it on the vehicle, and then show some failure modes and that kind of thing. So this system is a vacuum pump system, and we'll say they're relatively basic because many of the components are integrated with other components. So if you're repairing one of these systems, yes, there's going to be steps with testing each of these individual components that are part of a greater unit. But when it comes to replacement, you're not searching all over the vehicle to look for different pieces and parts to replace. Typically, you'll find most of them all in one unit, okay? This system, the vacuum pump system, key-off vacuum pump system, will be commonly found on most of our Toyota models that we're seeing in the shops nowadays. Now, we covered intrusive and non-intrusive. That was our older models. Now, pretty much everything from the beginning to mid-2000 range all the way up to today, we're seeing these vacuum pump systems on them in one shape or form or another. So chances are if you have a Toyota in the shop right now or a Toyota in your driveway right now, if it is not a Prius or a hybrid of some kind, it is most likely running the same system this Avalon is right here. All right, these systems are known to be very reliable. So that's good news, right? What's nice about these EVAP systems is it runs and passes the EVAP monitor test more often and more reliably than a standard purge seal system because there's less that can interrupt the test during mid-test. And we'll get into the test in just a little bit, but the number one factor here is the fact that this has to sit for 5 hours after the key has been turned off. We're sitting for 5 hours before we even begin the monitor, okay? So similar to an engine-off natural vacuum leak detection system, this system is waiting 5 hours for fuel stabilization and cooling or heating of the fuel depending on you know, the temperatures. But then from there, we are actually turning on a small vacuum pump and using that to draw vacuum into the system and monitor it, all right? That vacuum pump is typically going to be canister mounted as part of the canister assembly, all right? Sometimes the vacuum pump is replaceable, sometimes it's not. It's going to depend on the model that you are currently working on as well as the year and that kind of thing. So, continued, we have the vapor pressure sensor or fuel tank pressure sensor and the CCV or vent solenoid are going to be located internal to this vacuum pump assembly. All right, so guys, I've got a vacuum pump right here. This is the vacuum pump assembly that actually is the replacement for this vehicle, okay? Small in design, and this thing is going to be mounted directly on the side of the canister. I'll show you guys in just a minute. But this thing is going to house our fuel tank pressure sensor as well as our CCV or vent solenoid, okay? Like most vent solenoids, this vent solenoid is going to be normally open. This is a vented system, not like our intrusive, non-intrusive systems that are not normally vented. This system is going to be normally vented. That means at key on, engine off, we should probably see atmospheric pressure inside of our tank. If we don't, we have an issue. In the wiring diagrams, the fuel tank pressure sensor will commonly be listed as the leak detection pump. Don't get burned by this, guys. Basically, look at your wiring diagram and you should be able to count out the wires. The fuel tank pressure sensor part of it's going to run on 3 wires. Just know that that's the sensor that's being used to monitor the pressure and the vacuum in the system, all right? Guys, be careful when you're doing parasitic draw testing on these vehicles. The pump is going to kick in and it could throw you for a loop, okay? Now, a viewer had brought up in the last class, the 11 a.m. class, brought up that if you're parasitic draw testing and it's been 5 hours, chances are you're doing something wrong, and I agree. But there are some stubborn vehicles out there that seem to take a long time to do it. So know that after that 5-hour window is up, you're going to have a pump kicking in that is going to maybe throw off your readings, okay? And I'll show you guys exactly what that's going to draw here in just a minute. So I want to show you, this is what the system looks like on paper. We have our fuel tank, we got a line running off there going to our canister. Then we have a line coming off our canister to our pump module. That's this guy right here in my hand. This is our pump module. That pump module is then connected to some sort of external air filter or actually back to the air cleaner box depending on the model. And then we have a hose coming off of here going to our purge solenoid or our purge VSV. This is our purge solenoid. And then some vehicles have a service port. This 06 Avalon does not contain a service port, but some vehicles do. But if you don't, well then it's pretty straightforward. Like you normally would, unhook the canister side of the purge and smoke from that side. It's important to note that we have a restrictor in here, guys, okay? There's a little bit of information that I'll bring up in just a bit here about an orifice that's involved. But let's start by looking at some pictures of what I've got here, and then we'll show you guys in person. So here is our pump. Here's our canister assembly. This is going to be running to that air filter. Right here is that standalone air filter, and then this is going to go somewhere under the vehicle or potentially up to the air box of the vehicle. Here is going to be going back. This is our purge line. I'm not sure why I had that labeled as refueling valve. I apologize for that. This is going to be our purge line going to our purge solenoid. And then here is our fuel tank line. So really we only have 3 connections on this canister. And let's head over here. And you guys will see, whoop, check it out. Here's all, got a bunch of stuff in front of you guys here, but here is the canister that would go on this Avalon right here. And as you guys can see, there's really, it looks big and intimidating, but there's really not much going on. Here's our air line that's going to something, air filter. This is our breather line, essentially, letting air in and out of the system. Then we have our line going to our tank through a single hose, going to our tank. And then we have a line going to our purge solenoid. I mean, not that complicated. 3 connections, and then our, try not to trip here, guys. Then our vacuum pump here, right there, has 7 pins inside of here. Out of 10 total, there are 7 that are being used. And that is going to control 2 pins for our vent, 2 pins for our motor, and 3 pins for our fuel tank pressure sensor, or VPS. So nothing too crazy with the canister. It looks kind of big and intimidating, but once you start to break it down, it all starts to make sense. So let's look at, this is the vacuum pump. This is our part number ESM 1042. This is actually replaceable separate of the canister. Now a lot of these you are unable to replace separately. This one you are. So you get this vacuum pump, throw it on the side of your canister, you're good to go. And again, this is housing the vent, fuel tank pressure sensor, and vacuum pump all in one. Now as you guys can see in this picture right here, there's this very important spot right here. That spot right there is a 20,000th leak orifice, okay? This vacuum pump and the entire EVAP system on Toyota vehicles is intended that every time it runs a test, it checks what a 20,000th leak looks like and compares it against what is actually happening in the system. Now, I'll show you guys on the lab scope as well as on a graph in a little bit exactly what that's going to look like, but just know that basically, in most basic terms, every time this system runs an EVAP test, it's looking at what a 20,000th leak would look like, and it's comparing against what the leak is in the system on the vehicle. If it's above that 20,000th leak, well then we got a problem. If the vacuum drops below that 20,000th leak threshold, we're good to go. All right, so that'll change dependent upon temperature, fuel level, that kind of thing. So that is what that orifice is, and I'll show you guys. Actually, we can look at it right here as I take this apart. You guys can see inside of here. Now 20,000th is very, very small, so you probably cannot actually see the hole in there. But that's what this spot is right here, is an orifice for a 20,000th leak. All right, let's see what we got next. The fuel tank pressure sensor. Again, this is part of the unit. You can see right here is a little nipple here. That is where our pressure or vacuum is going to flow into this chamber underneath this plastic here where our fuel tank pressure diaphragm is actually sitting. All right, and then that will be then connected to 3 of the pins on the outside of this case. All right, so fuel tank pressure or vacuum is going to flow through this little port right here into this chamber here that's got our diaphragm for the fuel tank pressure sensor in there. All right, then we got our vent solenoid. This is our vent. All right, I think I got a close-up shot of that. There we go. CCV or vent solenoid. This is just going to be like a normal vent. Now, what you guys need to know, though, about this is that this one will not click. All right, I got power and ground here connected to a power supply back there. Uh-oh. Let's try that again. So, as you guys can see, it's opening and closing, but we're not getting a clicking sound. Okay, so keep that in mind. If you use the scan tool or jumper leads to control this vent solenoid, it is not going to click. That doesn't mean it's not working. It's not intended to click, okay? Don't let that throw you for a loop. So that's our vent. Let's get into the vacuum pump or air pump. This pump is designed to generate vacuum. It's just a little guy. This is all the bigger it is, all right? 2 wires, and it's not it's not a very impressive pump. Let's just put it that way. It doesn't draw very much vacuum. Now I'm going to go ahead and power this thing up and take a listen. You guys can hear it probably from my microphone. All right, that's what it's going to sound like. If you get a customer complaint of a whirring noise or some sort of noise from the rear of the vehicle after it's been sitting in their garage, it's normal. Chances are it's this thing kicking in. As we stress the pump, you'll hear the tone change. All right. So if I just block off the pump, you guys can hear that that tone is changing. This is what is essentially doing all the work of our EVAP system right now. This is intended to draw the system into vacuum and measure for leaks. All right, so I talked about parasitic draw, and we're measuring amperage. So why don't we measure the amperage actually on this pump? So I got a meter. I'm going to hook my meter up into series. This is a low amperage pump, so I'm not worried about blowing out the fuse of my meter. I'm going to go ahead and hook the meter up. So now we're running the amperage through our meter. You guys can hear it just turn back on. Get the meter on here, and let's take a peek at what we got. Uh-oh. Uh-oh. Shorten it together. The power supply survived. All right. So we're hooked up 46 milliamps. All right. If we deadhead the pump, 90, 91, under 100 milliamps, under 1/10 of an amp. All right. But we know our rule of thumb spec on parasitic draw is under 50 milliamps. Well, obviously this is going to throw off your parasitic draw test, okay? So be careful. If you have this thing kicking in the middle of your parasitic draw test, expect between 50 and 100 milliamps from this pump, okay? And just to show you guys that we are not doing a lot of work with this pump, let's get a vacuum gauge on here, maybe. There we go. As you guys can see here, we're not even creating, what is this? Inches of Hg. So we're creating what, maybe 1 inch of Hg? So we're really not doing a lot of work here. This pump isn't intended to, what could you compare it to? The secondary air injection pump or something like that. It's not intended to be a high amperage, high draw, high volume type of pump. Our goal is to just pump the EVAP system, pump vacuum, draw vacuum on the EVAP system, all right? Now, a pump this size will have a harder time drawing vacuum on an EVAP system that is completely empty. If you have a fuel tank that's very low in fuel volume at that point, it will take longer for the EVAP test to run. The pump will be on longer than a system that will be more full. The fuel takes up room. We wouldn't have as much of a system to draw vacuum on, okay? That is the vacuum pump. That is the key component of our vacuum pump system. 50 to 100 milliamps for this specific one. It's possible that there are some others out there that draw more. Just keep that in mind when you're looking at these things, okay? Now we get to the purge solenoid. Now normally, guys, I wouldn't have bothered opening up the purge solenoid or checking it out, but as you guys can see, there's something unique about this, and that's this guy right here. It's a screen or a filter or whatever you want to call it inside of this purge solenoid, all right? So here's what we got. This is actually off of this vehicle. We got a gray port and a black port. The gray port is going to our engine. Black port to the canister, all right? Now guys, what happens when a EVAP system fails, a canister fails, we get charcoal in the system, right? Through a purge solenoid or vent solenoid, it possibly ends up in our motor. Well, charcoal in our motor, probably not good for it, right, in our intake manifold. So somebody decided it was a good idea to put a screen in here. This little filter, screen, whatever you guys want to call it. The goal of this thing is to keep that charcoal from ever making it into our engine. If we look at this picture again here, guys, this port right here, coming in right here, this is the canister side. So if our canister goes bad and we shoot this system full of charcoal, it's all going to bounce off of the screen and fall down into this recess that's over here. So we should never, as long as our screen is intact, we should never see charcoal on the intake manifold side or actually stuck inside of the solenoid, because the screen is doing what it was intended to do, hold that charcoal back, okay? Now, as a technician replacing a purge solenoid, it would be a good idea for you to grab yourself a hammer and a screwdriver and crack open the old one, or a chisel. A screwdriver is not an appropriate tool. I guess a chisel would be better. But crack this thing open. It's super simple. Throw it in a vise, hit it on the seam right here, crack it open. If a bunch of charcoal falls out from that little recess inside of there, you have a canister that's failing. Now, it's possible if you were just throwing a new purge on, if this one had failed, but you don't exactly know why, it's possible that you would miss the fact that it's full of charcoal, and that vehicle will be back shortly when that one fills up with charcoal, okay? Commonly, you're going to see these things failing for a lack of flow, okay? That charcoal will eventually build up, and that screen will not be able to flow like it's supposed to. So when the system opens the purge solenoid, it's not going to be able to bleed off the vacuum quickly like it's supposed to. I'll get into the testing in just a little bit here. Alrighty, speaking of charcoal, here is what's inside of a canister, all right? As you guys can see, they are itty bitty little pellets. I think you guys can maybe see them, yeah. There we go. So that is what's inside of there. They're small little charcoal pellets that are intended to stay inside of the canister. They are held into the canister. Well, this is what the inside of it looks like. They sit inside of here, and they're held into the canister by a couple of these little screens right here, all right? So this is what it's supposed to look like in normal operation. Now I've cut these screens out so you guys can see behind them, all right? If this little screen, it's kind of like a fibrous little pad, if this were to become contaminated, start to break down, that is when you're going to start to have charcoal leaving the canister and ending up in your EVAP system. Now, what causes this to break down? Well, fuel vapors can cause things to break down, but what really does it is the raw fuel. You have a customer who likes to top off the fuel tank, eventually you will be seeing them in for a canister replacement, purge solenoid replacement, vacuum pump replacement, flushing of the lines. I mean, it becomes costly at that point, all because they're trying to get to that, you know, rounding to the next dollar or the next gallon, whatever it may be. When that fuel pump clicks, when you're filling up with gas, you're done, finished. All right, don't put more in there unless you got a problem in the system that it's prematurely clicking. But don't overfill your fuel system. You can saturate the canister and cost yourself a lot of money if you are for EVAP failure, okay? So keep that in mind. There's a very small, and I don't want to call it inadequate because it works and the system is properly designed, but that's not a lot of, as you guys can tell, it's not a very thick piece of whatever this fibrous material is. It's not very thick that eventually it can break down and cause your system to fail. Alrighty? So that's that. I think we can bump back over here now and look up. Let me bring you guys with me. The ducks aren't swimming around anyway, so they're pretty boring today. All right, let's get back to this. Actually, let's just see if you guys are commenting. Jeff is here, Jim's here. Ah, Glenn made it, all right. The fish tank is back. Oh, Keith is in here. You know, Glenn, there's always got to be one of you in every class, doesn't there? There's got to be. Oh, man. That's good stuff. Good stuff, guys. Thanks for joining and commenting in. You definitely make this fun. All right, let's take a peek at the wiring diagram. So this is what it's going to look like on a diagram, guys. Leak detection pump assembly. Like I said, we have 2 wires going to our canister close valve. We have 2 wires going to our motor and 3 wires going to our pressure sensor. Pretty straightforward. And then 2 wires to the VSV for EVAP, which is our purge solenoid. So these are all going to be commonly powered and individually grounded. Now, guys, I want to point out this right here. On our motor, on our pump, our vacuum pump, this is a diode, okay? This pump is intended to only be a vacuum pump, okay? We are intending this only as a vacuum pump. We do not want to be pumping pressure. So what do? We put a diode in the system. Let me grab my other lead here, and I'll show you guys what's going on. All right. So as you guys could hear before, we got power to power, ground to ground. Vacuum pump kicks in, right? But now you do it the opposite way. Power to ground. Nada. Ground to power, red to, try not to short them together. Nothing, okay? So that's a diode in there that's protecting our pump and making it only be a vacuum pump. Again, we don't want to be pushing pressure on this system. We only want to be pushing vacuum. I think I might have, I've tripped a circuit breaker inside of my power supply. That's what happens when you short it together. But yeah, that just brings, that was the point there, guys, is that this has a diode in it. And you'll see that also when we hook up the lab scope. You will see that at the PCM, we're going to read 12 volts on our vent and our purge, but our pump is not going to read 12 volts, and that's because of the diode that is in there, okay? Alrighty, let's see what we got here. So our PCM leak test, and that's what EVAP's all about. That's the bread and butter of EVAP, is figuring out how to test it for leaks. So you can do this with a scan tool, either as a manual or an automated test. Now our snap-on tool here will run both. It will also run control on all of our different solenoids. Now if you guys remember from the last class when we were working on that, what was it, a 97 Camry, our snap-on tool wouldn't touch it. Couldn't control anything, couldn't run any tests. We used the launch pad tool, the launch scan tool, to work on our 97 Camry. Now it's just the opposite on this 06 Avalon. Our launch tool will not run an automated or a manual test on this vehicle. It will control the solenoids individually, but it will not run the automated or manual test on this car, but our snap-on tool will. So guys, I know scan tools are very expensive. I know it's hard to sometimes personally own more than one. I just want you guys to know that different scan tool manufacturers and companies sometimes give you different information and different options, okay? So keep that in mind when you're diagnosing. If something doesn't seem right on the scan tool, try another one if you have access to it and see what happens, okay? Now, this leak test that we're talking about here is going to be run after a cold soak. Remember I had said 5 hours of soak time. Now, once that 5-hour soak time is up, the PCM is going to check out the ECT, coolant temperature, right? If it's 95 degrees and under, we run the test. If it's over, the system says, okay, it's too hot, we are going to wait 2 hours. All right, after that 2 hours, we're gonna check ECT again. If ECT is still above 95 degrees Fahrenheit, we're gonna wait 2.5 hours this time and check again. If it is still above 95 degrees Fahrenheit, we abort and we don't run the test until key cycle, okay? So, interesting scenario. You have a vehicle with a skewed ECT sensor, no codes, maybe it reads 150 degrees, 100 whatever degrees all the time and it's not coding in the system. Will your monitor ever run? The answer is no. The monitor would never run. If it never coded the ECT, it will never run the EVAP monitor. So you have a vehicle, no codes, not running the EVAP monitor, check out your ECT, make sure that it is reading accurately. Also, you have a vehicle for some reason I always use Arizona as an example, but somewhere very hot, a very hot climate, it's very hot out for a week straight. You're trying to run the EVAP monitor. If that ECT always reads above 95 degrees, you're not going to run your monitor, all right? You got to somehow find a way to get that car cooled down, whether it's putting it in the shade, getting it in the shop, something like that. You got to get that monitor or that ECT to cool down in order to run the test. All right, guys, if the test fails, it's obviously time to start looking for a leak or looking for something else in the system. And guys, don't forget that your purge can leak, okay? And I'll show you guys what I'm talking about in just a second. Now, guys, behind me is a 2011 Prius. Now, in the Tech Connect episode, I told you guys that I was working on getting a Prius in here. And I didn't lie. I got a Prius in here. Now, the downside is the Prius is using the exact same system that our Avalon is using. Unfortunately, it is not a Gen 1 or Gen 2 Prius. I wanted to demo the Bladder style system. And unfortunately, the Prius that I got my hands on does not have that system. Now, the reason that it's in here is, first of all, because I got a Prius in here when I told you guys I would, but also I want to show you guys the canister under there and how this one is much easier to get to than our Avalon. Book time on that's only about 9/10 of an hour or so to replace the canister assembly on our Prius versus our Avalon that is well over 2 hours involving dropping the fuel tank down and that kind of thing. So not every canister and leak detection pump is the same. So you can't just make a quoted labor time for one or the other. You're going to want to look it up because you don't want to be losing out when you got to do an Avalon one. They can be a pain to do. And that is the exact reason why you can see my scope leads coming out of the passenger side window. I'm hooked into the PCM. All right, so here is the passenger side glove box. I have the glove box removed, and I am back probed into the PCM for all of my signals on the scope. Man, it's hard to talk right now. Drink of water, hang on. Okie dokie. So we're back probed onto there. I'll show you guys on the scope in just 1 second. So that's the reason we're back probed at the PCM is because this canister on this one is a pain to get to. All right, this PCM leak test, I broke it. It's broken down into multiple steps here, A, B, C, D, and E. When we get to the scan tool, you guys will find that it's actually broken down numerically instead as 1, 2, 3, 4, 5, 6. All right, I'm just going to go through this very quickly, and then we're going to actually go through it with the scope and the scan tool. Step A, we're going to run it for 10 seconds. Our vent solenoid is off. The PCM is just looking to measure atmospheric pressure. Remember, guys, I said that this was a vented style system. We are looking for atmospheric pressure on step A. Nothing is turned on. All we're doing is measuring what's inside of the tank right now. If our parameter, or if our pressure is reading below 70 kPa or above 110 kPa, we stop the test. That means for some reason there is either vacuum or pressure inside of our tank. We're looking for a specific amount inside the tank, and if it is out of those parameters, we are going to stop the test because it's possible something like the vent solenoid is stuck closed or plugged up, or there's a restriction or something like that. So that is the point of step A, is to build and get a known good atmospheric pressure. Step B is where it starts to get interesting. We turn on our pump, okay? Our pump turns on. Our vent solenoid is still open, okay? Our system is still vented. Our pump turns on. We're drawing vacuum now through that 20 thousandths of an inch orifice to determine what it is supposed to look like. This determines the normal operation of the system, and we have a spec here between negative 4.85 to negative 1.057 kPa. All right, guys, to make that sound even easier, what we have, this is sitting on the floor, I must have dropped it. We have this vacuum pump, okay? And this vacuum pump has this orifice in it. This orifice is through a small tube in here that is connected directly to our vent solenoid. All right, our vent solenoid sits directly on top of our orifice. Our pump turns on. Our path right now is directly through our 20 thousandths leak orifice. We are not measuring the system, okay? I need to stress this, you guys, that if you turn the vacuum pump on and the vent solenoid is off, you are not measuring or drawing the system into vacuum. You need to close the vent in order to put any sort of vacuum on the system. And I'll show you guys and prove it in just a second here, but I need to stress, when you turn on the vacuum pump, you are only measuring across that 20 thousandth orifice. And this is what the computer is using to determine what that looks like at that specific fuel level, temperature, and volatility, okay? All right, so now step C. Step C is where we're actually measuring the system. So what do? We close up the vent solenoid. Again, that closes our back door. If you guys remember the analogy, purge solenoid was front door, vent solenoid was back door. All right, we close up the back door, the purge solenoid is off, so that's closed. Now we have our vacuum pump drawing vacuum down on our entire system, okay? The goal here is to get that vacuum level to reach lower than the threshold that our 20 thousandth leak was at. So the computer pulls a 20 thousandth leak, measures what that is, and says, okay, let's measure the entire system and make sure that we are below that threshold. If we're below that threshold, we pass the test. If we're above that threshold, depending on what level that is, will determine a small leak or a large leak. All right, so step D, after we've pulled down into a vacuum and achieved our threshold, we open up the purge solenoid. The CCV or vent is still closed and the pump is still on. We should see a fast decay in our vacuum level. Our vacuum should quickly return back to atmospheric because our purge is a large leak in the system. Okay, that is where our purge could cause a leak issue, so keep that in mind. But our purge is going to be opened and we should see that return very quickly. And then step E is going to be a re-verification of that 20 thousandth leak, and then the computer does the math. It starts to compare those two 20 thousandths leaks to the vacuum that was drawn in step C. If step C's vacuum was greater than 20% of step E, we have a small leak. If it was between 0 and 20% of step E, we have a large leak. Now that sounds confusing. Here's what it actually looks like on a graph, okay? So this would be step C. If we are somewhere between the 20 thousandth leak and 20% of our 20 thousandth leak, we have a small leak. If we are somewhere between the 20,000 leak mark and, 20% of the 20,000th leak mark and above to atmospheric, we have a large leak in the system. That is how it is able to determine between a small leak and a large leak. All right? So anywhere between here and here would be a small leak, and anywhere above 20% of a 20,000th leak would be a large leak. Now you could get the values and do the math. Doesn't really matter at this point. You guys just need to understand a large leak is something that is not able to pull at least 20% of a 20,000th leak, and a small leak is anything that is above that but still does not cross our threshold, okay? So here's what we're doing. Step A is right here. We're going to let this thing sit for 10 seconds and kind of normalize that atmospheric pressure. Step B, we're going to pull the system down into vacuum. But when I say system, I don't mean we're pulling the entire system. What I should say is we're pulling a 20,000th leak into vacuum. So what we're doing is we're just measuring across that orifice to figure out what a 20,000th leak looks like. All right? At that point, what do? We turn the vent solenoid on. So now our vent solenoid is turned on, and now we are drawing vacuum on our entire system from purge solenoid to gas cap. All right? Pulling vacuum on the entire system. Once we achieve a certain level within a certain time frame, we open up the purge solenoid. We should see our vacuum quickly dissipate and go back to atmospheric levels. That is going to tell us that our purge was able to physically open and bleed off our pressure. At this point then, we reclose our purge. We shut off the vent, which is going to open it. So now our system is venting to atmosphere, and we pull another 20,000th leak check, and then we return it back to atmospheric. All right? Kind of maybe a little bit confusing, but I think I'm gonna demo it here, guys, and I think by the end of that, it'll all click and make sense. Before I get to there, I want to show you guys, here are the codes that could set. Now, I'm not going to go over every code in this system. I just want to call out a couple things. One, you guys can see the P043E and F and P2401 and 2, 2419 and 2420 are manufacturer-specific codes. These are not generic codes. These are not P0 through P1000, so it's possible if you're using a generic scan tool, you may not be able to get these codes related to your leak detection pump. So be careful if you're using a low-end code reading tool, okay? You might not be able to pull these codes. Also, what I want to show you guys is the fact that one problem may include multiple codes. So you have a 20,000th orifice that's clogged. You could potentially set a 43E or F, 2401, 2402, or 2419, or all three of them, okay? So keep that in mind. If you have multiple codes in the system, it could be because of a singular problem. Same thing with this 441 code. If your purge is stuck open, you're going to set a 441, and you could also set a 455 code because you're never able to pull the amount of vacuum on the system. So, and then vice versa. You have a gross leak, you're going to set a 455, and you're going to set a 441. So guys, I don't know if you're familiar with with screenshotting or print screen, but at this point, guys, this is a nice little tidbit of information. Hit the print screen button on your computer, grab it, and copy this and throw this in a folder. Next time you're working on a Toyota leak detection pump system, you can look at this, and that should be able to help you, all right? Put it on a folder on your desktop as Toyota references, because I can't tell you how many times you're looking for information on a specific code, or you're maybe stuck on something. This is good information right here. Fortunately, Toyota's really, really good about sharing this information as of today. You know, that could all change in the future, but as of today, they're really good at sharing this information. This is directly off of Toyota. I have, like, this graph here was directly from Toyota as well. These are all Toyota graphs, so they're really good at sharing information as of right now. All right, so before we get to the Bladder style system, I want to show you guys what this thing is going to be doing in real time. All right, first of all, I want to talk about this because this thing is awesome. It's new for us. Milwaukee was actually nice enough to send us out this underhood light. I've been looking for an underhood light for a while so I can be able to show you guys what's going on under hood. This thing is pretty awesome. I mean, I don't know if you guys are into Star Wars or not, but this thing is practically a lightsaber. I mean, it's pretty cool. It's got two settings of brightness. But what I like the most about it is you can tilt it anywhere you want and it'll stay there. All right, so if you're working on the back of the motor, you tilt it back that way, tilt it forward, whatever, it slides side to side, and it's battery operated on the same M12 batteries that you're already using in your little 1/4-inch ratchet that a lot of you probably have. I know I have one at home in my toolbox. So it's just another handy tool, and Milwaukee was nice enough to send that our direction, so I got to kind of talk about it because I like supporting another local Wisconsin company. So thank you, Milwaukee, and I hope you guys like that light as well. If you have one, let me know what you think of it. Okay, let's flip the key on here, and let's play with this system. There we go. All right, so I already have the scope all loaded up for you guys because I didn't want to have to spend too much time getting this all put back together, you know, just to help save time. So channel A, guys, is going to be our fuel tank pressure sensor. B is our vent. C, our vacuum pump. And D in gold will be our purge. So immediately upon key on, you guys can see that both our purge and our vent went up to the 12-volt rating, which is what we would expect. The solenoid is not currently being grounded, so power flows through the windings to the end termination point where I am hooked into the PCM. Also, guys, you notice that our scope has started on the right side of the screen here. At Automechanica, I attended one of Matt Fanslow's classes on Intro to Pico, and I picked up a little tip from him. He had brought up, we're on a 20-second division here, guys, so you know when you're looking at a long time frame like this, the screen will fill and then reset, fill and reset, fill and reset. But if you want to see everything and you don't care about having a buffer, you can set a single trigger at a limit that's out of range. So I know this fuel tank pressure sensor is never going to read now I just moved it and it reset. All right, but our fuel tank pressure sensor is never going to read up around the 4.7 mark. So we are going to fill this entire screen, and then we're going to continue it going in real time, all right? This is just a benefit when you're doing a test like this that happens over a long amount of time, but you don't really care about having a buffer to be able to go look at. This will keep it going real time, all right? So let's actually start to run the test. Now I'm going to go ahead and I'm going to go into System Tests. And I'm going to pull, sorry if you guys can hear the rain, it just started raining. Well, it's been raining this morning, but just started picking up again. All right, I'm going to go into manual test mode. You could do automatic as well. Actually, you know what? I'm going to back up 1 second here, guys. I ran the manual test mode on this morning's class, and I found that when it went into the purge solenoid test piece, this part right here, when it went into this, I found that the scan tool, or the PCM, whichever one was actually in control at that point, was pulse widthing the purge open and close very quickly. It didn't fully open the purge to drain our vacuum off quickly like this. Even after 10 seconds, we still had a significant amount of vacuum in our fuel tank. So I don't know if that's a scan tool thing or if that's something with the PCM on this vehicle. So what I'm going to do this time, guys, I'm going to run this thing in an automatic mode, and we'll see what exactly happens. Now with the automatic mode, unfortunately, I will not have control over what it's doing. We'll just have to keep an eye on it. The automatic mode does also take a little bit longer. But let's see what happens to that actual purge part during the automatic mode. So here we go. So we're going to simulate the monitor, yada, yada, yada. To prevent damage, is just telling me that the vacuum pump, it'll stop the system and stop the vacuum pump if pressure drops too low. Make sure the ignition is on, engine not running, because again, this is a key off system. Our fuel temp needs to be below 95 and our fuel level less than 9/10. Key off for 10 seconds, do not apply brake. All right, we'll turn the key off. 1, 2, 10. That's flat rate math right there. All right, do not start engine, do not apply brake pedal. I don't know what applying the brake pedal has to do with anything. That's kind of odd. You guys can see on the scope here where I shut the key off, everything went back to 0, and now we're back on. EVAP can only be activated every key cycle. Okay, we haven't activated yet this key cycle. We'll simulate the system monitor, continue. It says here 8 to 15 minutes. We'll see if it actually takes that long. I doubt it will. All right, so we're going to initiate the test. Now step 1, or A, or whatever you want to call it, is going to be that initial checking for atmospheric pressure. So right now you can see right in here we are reading 0 to right around 165 millimeter Hg, 0.165 millimeter Hg. So we are reading atmospheric pressure right now. Our fuel tank pressure sensor is staying even where it's sitting and our vent and our purge are off, and our vacuum pump is off. Everything is off. We're letting the system stabilize at this point. Let's keep watching and see what happens here. And eventually, this will turn our vacuum pump on and run our 20,000th leak check. It does take some time. If we looked at our graph again, it says that this is going to take 10 seconds. Well, we're already past 10 seconds. Let's see what you guys are saying out here. Luke Skywalker stunt double. Nice. I have both my hands though. Isn't Luke Skywalker the one that got his hand cut off? All right, back to the scope. It just did something. All right, our vacuum pump turned on. Green is vacuum pump. You can see it goes from 0 up to the 12 volt mark. It turned on. Look at our fuel tank pressure. We dropped it down here. This is our 20,000th leak mark, all right? So guys, I'm going to bring a cursor in here, and I'm going to throw this cursor right across the, I'm going to try, right across the top of this mark right here. This is telling me this cursor is our threshold. This is our 20,000th leak mark. So as you guys can tell, our red line here is our vent. This is our vent solenoid closing. And you guys can see already we're starting to reduce in fuel pressure or building of vacuum. And you can see the number actually on here increasing. All right, so our vacuum pump is on, our vent is on, and we're pulling vacuum on this system. So eventually this thing will reach a threshold which should put us below this line right here. We should be able to drop below that. That will tell us that we have a good running system. Oops, sorry guys. Go back to that one. And you can leave the scan tool up on the screen. That way they can watch the actual pressure value building. So right now we're at, let's call it 14 millimeter Hg, negative 14 millimeter Hg. Now guys, I'm no scientist. I don't know what negative 14 millimeter Hg means, so I'm just going to go to Google. Let's go negative 15 millimeters of Hg. So we're roughly let's call it a negative third of a PSI inside of this system right now. So we're dealing with a very, very, very small amount of pressure or vacuum inside of here, okay guys? We're not dealing with large numbers here, very, very small. Again, this is why you use an EVAP system smoke machine and you don't just pressurize it with shop air. So it looks like we're still dropping in vacuum. Our vacuum is still dropping, but look at our threshold, guys. We're getting really, really close here. I would say we're probably pretty close to where our 20,000th leak mark was initially. Now, for those of you that are keen on what the scan tool is reading, if you pause the video and were to go back, you would actually be able to get a numerical value of where it was during the 20,000th leak test. But just by looking at it on the scope, I'm saying we are getting really, really close here to the point where the computer is going to be like, okay, we're okay, we don't have a leak, we pulled more than 20,000th, I'm happy. Now let's go to step, what was that, D, where we open up the purge solenoid. So we should see our yellow line at some point here open. With our vent and our vacuum pump still on, we should see our fuel tank pressure return to atmospheric relatively quickly. All right, we're still dropping. We are definitely underneath our threshold now. And we're just about to lose it off the end of the screen, but this was our 20,000th leak. Where I set our threshold, we are definitely, oh, there we go. So it just happened. Our purge solenoid turned on, and guys, look at that. Now, if you were here for the first class, you saw that when I did it in manual test mode, that this line here was really jagged. It was pulse width driving our purge solenoid. In automatic test mode now, it was a direct 100% wide open for however many milliseconds that this would be right here. I don't want to stop it because I don't want to stop capturing. But our purge solenoid turned wide open, and our fuel pressure here, vapor pressure, returned back to the atmospheric level. And then after that happened, what did we do? We reopen the vent the system out, and we pull a 20,000th leak check again. We obtain that 20,000th leak check, which you can see if you look really, really close here. Actually, let's go ahead and stop this right here. And let's zoom it in, right there. You guys can see, boy, it's really hard to tell, but I would say that this spot right over here is lower in voltage than this spot over here. Okay, you can see that this is relatively steady across the top. I know that our fuel tank pressure sensor on this thing is kind of messy, kind of dirty signal, but you can see that this is lower than this one, meaning that we are passing our test. We've achieved a vacuum level greater than the vacuum obtained through a 20,000 leak. The system is happy, good to go. You can also see that this opened up relatively quickly. You can kind of see that bent line in there. Looks a lot like this, right? So our system is happy. The EVAP system check was completed. Next step, we'll check and display any codes that were set. Just see if we got any codes. No codes present. All right, so we were able to pass the automated test on this thing. That is what it is going to look like and what the computer is doing in real time, looking at it with a scope. All right. Now, what if we had a leak? What if we failed? Oh, I think my mouse just died. Oh, we're good. What if we failed the test? All right, let's just see. Nope, no more comments. What if we failed this test? What if we came up saying that there was a large leak or small leak? What do you do next? It's not going to be that much different than a normal testing, smoke testing, or pressure testing of a normal purge seal system. What you'd have to do is you'd have to close up your vent solenoid and hook up your smoke machine or your pressure. So I'm going to back out here. First of all, I just want to show you guys something. Oops. We'll go into actuation test. And I want to grab the vacuum pump. I just want to show you guys this vacuum pump control. I don't really care about the data at this point. We'll watch it on the scope. Okay, so I'm going to go ahead, as soon as this loads, I'm going to flip the vacuum pump on. So I just want to prove to you guys, beyond any shred of doubt whatsoever, that this system is only looking at, oh, vent solenoid down, only looking at our threshold. And you can leave the scan tool up on the screen, that's fine. We're only looking at that. Let me grab this over here, guys, and let's bring you into this motor over here. And, all right, so as you guys can tell, there is a nice new purge solenoid on this motor. And now sometimes with Toyotas, oh, sorry guys, with Toyotas this can be a tricky endeavor because right here is also a VSV. Now, I know I'm currently have the vacuum pump on, but I want to talk about one other thing quick. This is the lovely diagram that's found under the hood that tells us what's going on in this system, all right? So we have 3 vacuum switching valves under the hood of this vehicle. And Toyota's nice enough to label them all for us, right? So we got a PWM vacuum switching valve. Oh, look, another PWM vacuum switching valve and a normal vacuum switching valve. All right, guys, this is kind of tricky, but basically look for the hose that's going back to the canister. We know our purge solenoid is connected to the canister. This hose is going to come up somewhere from the back of the vehicle into our purge solenoid. So when you're looking under the hood of the vehicle, look for the one that has 2 hoses, one going to the intake manifold, which would be actually this one here, and then one going back to the canister. All right? So that VSV word is thrown around a lot under the hood of Toyotas, but look for the one going back to the canister, okay? All right, so you guys can see that pretty clearly. This one was replaced. The one that was actually bad was the one that I showed you guys just earlier that was stuck open partially. So what I'm going to do, guys, is I'm going to pull this hose off, all right? So you can see that is the hose that's going back to our canister. Let's look at the scope again. Look at that. Vacuum pump has been on this entire time, so 2 minutes ago, we're still running live. We're currently measuring a system that is open. All right, let's take it one step further. You guys stay on the screen. I'm going to go pull the gas cap off this thing. All right, gas cap's in my hand. No change in our pressure reading, all right? So that, guys, I need you to really take that. If you take anything home from this class, anything, one thing, the fuel tank pressure sensor is not truly a fuel tank pressure sensor. The sensor is mounted inside of this assembly, not in our fuel tank, okay? If you put on just the vacuum pump without closing the vent solenoid, you are only drawing vacuum across the 20,000th orifice, okay? Let me go ahead and turn this off now so I don't burn up the pump. All right, so the system obviously is currently open and we don't have a leak. Our vacuum pump was able to pull because it is not connected to the system right now, okay? One thing to take home from this class, if you can take that home out of this, you will be doing well for the day. All right, let's just hook up a smoke machine really quick. I just want to show you guys that you can smoke this just like anything else you would be smoke testing. So I'm going to go ahead and get this guy running. I wonder if I'm almost out of smoke juice. Or my battery's going weak on the car. It's pulling power off our battery. I think my battery might be starting to die. All right, I don't know if you guys can see, but I definitely have smoke coming out of here. So what am I gonna do? Feed it into the canister side of the purge solenoid, just like so. I'm gonna exit out of the scan tool, and I'm gonna go ahead and I'm gonna grab the vent valve control. And let's look at the scope also. Oh yeah, we're definitely losing battery voltage here. You guys can see we're dropping voltage. In fact, I wonder if I'll just start this thing up quick. Can't run it for too long. I don't have a hose on the back, but that's okay. Hopefully it starts. Okay, that's all right. Nah, don't worry about it. Thanks though. Okay, so we can still, hopefully, I can still show you guys this. Oh, I don't think it's gonna let me run the smoke machine right now. Nope, battery's too weak. All right. Well, instead of wasting the time to throw the charger on it, guys, what I basically just wanted to show you here was the fact that you put the smoke machine into the purge solenoid port and go to the back, pull the gas cap off. Make sure you get smoke back there, right? Just like that Alero that I did in that video, verify that you have smoke back there so you're actually making it through the entire system. This Avalon, you will flow smoke through the entire system, and you'll see it if you pull the gas cap off, okay? Simple as that. That's what I wanted to show there. You will also see the pressure increase on our scope. So if anybody does want to see that, let me know. I will take the time to throw the charger on it if you think that is valuable information. Otherwise, we're going to go ahead and move on to the next. All right. Moving Up DIY is back. He says, hey, what's up? Glad you made it back for the second one. I believe you were here on the first one, right? So thanks for joining us on the second one. You're really getting your Toyota EVAP training today. Okay, guys, let's go over the bladder system on the Prius. Now, guys, like I said, unfortunately, this Prius that's up on the hoist right here is not a bladder-style system. That is going to be found commonly on the Gen 1 and Gen 2 Priuses. What is the bladder-style system? Well, just like it sounds, there's a bladder inside of the fuel tank that expands and contracts with fuel. Think of it kind of as like a balloon inside of the tank. And so that's what I've done here. I have a balloon inside of the tank, right? We have our bladder inside of here, inside of our physical fuel tank. Now the whole goal of this, the point of this, is to reduce the area in which fuel vapors can form. We want to keep the amount of fuel vapors down on a hybrid because we don't want to have to start up the internal combustion engine just to purge off the canister, okay? So we want to try and make less room for vapors to grow. So if we have a balloon or a bladder inside here that expands or contracts with the fuel, we're not going to have any room for air, which is not going to allow for any room for vapors, all right? So this system still uses a purge solenoid and still uses a fuel tank pressure sensor, but the pressure sensor is reading on the tank, not on the bladder, okay? That's really, really important to know. And there are two bladder systems. I'm going to go over both here to just bring up the differences, but they are very similar. Okay, so this is what it's going to look like. It looks a lot different than a jug with a balloon in it, but basically we have a bladder inside of our fuel tank that is connected up to our fuel pump, and this bladder would shrink as our fuel level goes down and expand as we increase fuel level, okay? We have a vent solenoid over here. We have a vapor pressure sensor right here, and then we have a bypass switching valve right up here and a charcoal canister right here. All right, so that's basically, oh, and then of course we have our purge solenoid over here, all controlled by the PCM. Here's what the system is going to look like under normal operation. We turn the purge solenoid on and we are drawing vacuum on the system. Now it's important to know, guys, that this is not fuel vapors inside of here. If this bladder is intact and in good shape, there should be no fuel vapors outside of it, okay? If this bladder were leaking, well then we're going to have fuel vapors out here. But if it is in good working order, we will not have fuel vapors outside of our bladder, okay? So we are really only drawing into this system through, not this way. This is not, this switching valve right here is going to be open. We are drawing through our canister into the intake manifold. Now it's important to know, guys, when you're doing these systems, look at your fuel trims. That initial, okay, your vehicle's been sitting, that initial turning on of the purge solenoid, you should see your fuel trims do what? Remember, this was a question that we had asked a while back on one of the fuel trim classes. On a normal purging sealing system, like on a GM or whatever you want to call normal, you would expect to see those fuel trims rich in, right? Because you're drawing in fuel vapors that were inside of the canister. On a bladder style Prius system like this one, you should expect to see the fuel trims go positive because you're actually leaning the engine out by inducing air into the system. Now, there's a high probability that the computer will already have predetermined that this should happen and adjust the fuel trims automatically or adjust the table that it's pulling from automatically. But if you see your fuel trims go positive during purging, that is because we are just drawing air like we're supposed to be. If you see those fuel trims go negative, that is because this bladder here is leaking. We're getting fuel vapors inside of our tank, which is then being purged into the engine. So if you see negative fuel trims, meaning that our engine is running rich and we're trying to pull fuel away during purging on a bladder style system, you have an issue, okay? It is not intended to go negative. That means you have fuel vapors outside of the bladder for some reason, okay? Keep that in mind. That's a good little diag tip. Here's what the system looks like when it is testing. So we're going to have the purge solenoid closed. You know, our front door is, well, first of all, it's going to open and draw vacuum. Because we're going to close up our vent, our system is now sealed. Draw vacuum on the system. This bypass here is switched open, so we're actually going to draw vacuum down this path. It doesn't really make a difference what path it's going to take. They both go to the same spot, and they're both connected to the tank. I don't know why there's two separate paths, just the way that Toyota designed it. But now we are not going through the canister this direction. We're actually drawing vacuum this way, all the way back up through this channel right here, okay? So we're pulling vacuum on the system. It's basically a purge seal system at this point. We run the purge solenoid, draw vacuum on the system until it reaches a certain threshold on our fuel tank pressure sensor, and then we open the purge or open the vent or whatever to check for the rest of the system. So pretty simple for that one. But here's a diagram. Again, not something terribly difficult. We have a V2 VSV. This is our what is this, our purge solenoid, right? Yep, this is our purge solenoid right here. Then it looks like we have some power coming out of our EFI main relay, flowing down through a splice or a junction of some kind into our VSV purge flow switching valve. This is that switching valve that is right here. And then we have our canister close valve, our CCV, or our vent solenoid, whatever you want to call it, also being power fed by a common power feed and ground side controlled by the PCM. And then we have a fuel tank pressure sensor, which has inputs directly in and out of the PCM, just a standard 3-wire sensor, okay? Another drink of water, sorry guys. Throat's getting raspy from all this talking. All right. Now, before we get into the later model bladder system, I want to show you guys something, a little bit of a phenomenon. Now, guys, I know I've said it before, and I'll say it again. I'm not a scientist. I am not an engineer. But I like to have examples for you guys. I like to try to build things or do things that you normally wouldn't think to do or that you normally don't get to see, you know, like the fish tank or something like that. So I developed a bladder-style system right here. We have a vent. I don't know if you guys can see. It's kind of like red colored right there, maybe. Yeah. So it's just a hole in our tank. That is our vent, okay? And we have a bladder inside of there, which is just a balloon. And we have a hole in the top of this where I'm going to be feeding air into it. And this would be just like you're filling the vehicle with fuel. All right? So on a normal operating system, we start to fill with fuel and our bladder expands. This bladder now starts to take up room inside of our tank. So what happens? It forces any air that needs to be displaced, it forces it out of our vent solenoid. So our tank should never change in size as long as the bladder doesn't overgrow the size of the tank, okay? Now, if we were to do this same thing with a stuck, closed, or restricted vent, you guys will actually see this tank expand. And if I force too much, it'll blow the balloon up, potentially, or blow this right out of here. But I don't know if you guys saw that, but the tank actually expanded. Kind of hard to tell. But you could hear that pressure, right? We are displacing air inside of the tank inside of this bladder right now. Now this also works inversely. All right, so we have this bladder that's full in here. Now say that you're using fuel, you're driving down the road using fuel, and you have a plugged up vent solenoid. So I'm going to just throw some tape over this. Our vent is now plugged on this motor. All right, you're using fuel. Your bladder stays inflated because there's nowhere for, the tank itself is actually building vacuum. There's no way for that bladder to draw back down or contract because of the vacuum that's been built up inside of here. You guys have seen this actually on, if you got little plastic gas cans, you leave them out in the sun and they're sealed, they expand. You pull them into the shade or put them somewhere cold, they'll actually contract as they're sitting there. That's because of the way the fuel vapor pressurizes or contracts. This is very similar. All right. The second we open our vent solenoid back up, we'll see our bladder actually return back to its normal state. Guys, this is not no trick or anything. I mean, here's a screwdriver. All right. So I'm down inside of the bladder. There's nothing blocking that hole. It is strictly because of the amount of vacuum that is stored inside of our tank. So if I let our vent open, there we go. The tank goes back to its normal size and the balloon or bladder shrivels back up. If I had a harder piece of plastic, we would actually have seen our balloon significantly larger, but actually the tank started to cave itself in under the stress of the vacuum that was trying to escape from our bladder. So this is important, guys, to know for these bladder systems because we could end up with pressure ending up in our bladder that's not supposed to be. So it's possible you're trying to fill this thing up with gas and you know that you have a bladder system, but if that's not supposed to have any pressure or vacuum inside of it, but you have a plugged up vent, you might not be able to fill this system with fuel. You could end up with spit back out of the filler neck. You could end up with sloshing of the fuel, maybe even aeration of the fuel. A lot of different things that could happen because this system was never designed to have extra space, extra room inside of the bladder. That bladder is supposed to remain the exact same size as the fuel volume. Okay? Let's see if you got any questions. How many inches of water did you drink? I don't know, not enough. My throat is real scratchy today, guys. I'm sorry. I just get so excited that I'm talking loud and my throat's all scratchy. Sorry. All right, let's get back to the later model system. Now I'm going to put this away. The later model system is also going to be using a bladder, but now we throw a vacuum pump into the mix. These systems actually use 2 canisters and 2 vapor pressure sensors, 2 I'm not going to call them fuel tank pressure sensors because that wouldn't be accurate at this point. We're using vapor pressure sensors in 2 different spots on this system. What's nice about that is we are able to compare those pressures between their locations of the tank and the canister. This system is basically going to be a key-off vacuum pump system, which is nice because you're going to diagnose it the exact same way as you would this one. Okay, so let's see what that looks like. So we got a bladder inside of the tank again. Same looking thing, feeds the fuel pump. We have a fuel tank pressure sensor right here, which goes up to a switching valve, our canister, going to our purge solenoid. This all looks exactly the same. What's different here is this trap canister with pump module. Okay, this is the difference right here. This is not anymore just a standalone vent solenoid. This is a canister with pump module, so it's going to be something that looks like, well, if it wasn't in pieces, that looks like this, okay? This is what it's going to look like on a diagram. Fuel tank pressure sensor, excuse me, I can't call it fuel tank pressure sensor. This sensor is mounted and measuring on the canister pressure sensor. We have our leak detection pump, again with a diode, and we have a vent valve in here, okay? So this system does still use a vent. And then over here we also have another vapor pressure sensor. This is the one mounted in the tank right here. All right, so this right here is equivalent to our trap canister with pump module. This vapor pressure sensor right here is our tank sensor. Okay, so what does that matter? What do we care? Well, first of all, guys, you can see that in this diagram, sorry Dave, I'm making it, switching it all over the place. You can see in this diagram it's very, very similar looking to what we dealt with on the Avalon sitting here. We have our normalization period, we have our 20,000 leak check. With our pump on, we turn on the vent and we draw vacuum into the system. And then we turn on the purge, we should see that vacuum decay very quickly, and then we draw another 20,000 leak. So this system right here is being tested basically the exact same way as our Avalon over here. All right. Now, guys, I had a question about fuel level on these bladder style systems, and I didn't get into it in the first class because I don't have the information here in front of me. I will be gathering some information and hopefully I'm going to try to get another Prius that has a bladder style system for the Tech Connect episode at the end of the month, when we are going to actually be talking about fuel level and the complaints that Prius owners with bladder style systems have with their fuel level indicator. Okay, but that's for another time. We do not have enough time to discuss it, but there was a question on that during the first class. Okay, so that any questions about the bladder systems? That is going to be both of the bladder systems from Toyota. One is basically going to leak test with a purge seal, the other with a vacuum pump style. Okay? Any questions on that? Let me know. I will cover more if you'd like. All right, looks like Glenn is heading out, but he'll pick up later. Thanks for staying, Glenn. Sounds like you gotta get back to work, but let me know what you think in the comments later on. Glenn said he's got plenty of smoke if we need some. Good to know. All right, let's get to the final system. This is called the hybrid closed system. This is going to be used on non-Prius hybrids like your RX350H, 450H, Camry hybrid, Highlander hybrid, any of the hybrids that are not a Prius, okay? Will be most likely using this system. It is possible that they're using a leak detection pump system, but more than likely they are using this hybrid closed system. Again, your best bet is to verify in service information. What is the hybrid closed system? This is a closed style EVAP system which uses a vacuum pump as well, which sounds confusing. And this system is not easy to explain. So I will go through this and then we have some graphs coming up. So a normal system when it's purging, a normal purge seal system, when it purges, it will actually draw a slight amount of vacuum on the fuel tank. That vacuum will then create a space for fuel vapors to be made. All right? Again, we're working on a hybrid here. Our goal is to reduce as much fuel vapor generation as we possibly can because we don't want to be starting up that internal combustion engine every time we just need to purge out the canister because our fuel is creating a ton of vapors. We want to be able to you know, use the internal combustion engine to create heat or run an AC compressor or whatever. Hybrids are, I don't know. Hybrids are hybrids. We'll just leave it at that for now. And just to clarify, there are some hybrids out there that will run an electric pump for heat, or it'll run the AC compressor on the high voltage side as well. But yeah, that's for a different time. Okay. Our tank and our canister on these systems are split and separated, similar to our non-intrusive system. Okay, these are two separate units that have a door in the middle, so it's kind of like our intrusive style. We have a door in the middle that opens or closes a pathway between the canister on this side and the tank on this side. Okay. On this system, the tank is intended and allowed to build pressure on its own. When purging, the computer will typically not open that door and only purge out the canister side of the system, all right? This then does not induce vacuum onto our tank, which gives space for growth of fumes. This allows our tank to be sealed over here doing its own thing, and we're going to purge out the canister. The reason that the canister might end up with fumes in it is if we overcome the mechanical valve limit of the tank. That's going to be called our fuel outlet valve. That is going to open during an overpressurization event. Unfortunately, guys, I do not have the spec on that. I wish I did. But at some sort of pressure, that will allow the tank to essentially burp out its pressure into the canister side, which will fill the canister, which will eventually need to be purged out. But this is under a pressurization point. Again, I do not have the spec on that. Our fuel containment valve is our bypass door that the PCM is controlling to isolate the tank half and the canister half. When the door is closed, we have two halves. When the door is open, we have an entire system, okay? Similar to our intrusive style, not like our non-intrusive, which always separated the systems, and the door was only to the fuel tank pressure sensor. This is different than that, okay? This thing checks its leaks by using the vacuum pump, and I'll get to that in just a second, how exactly that's happening. Here's what the system looks like. We got a fuel tank, we have a filler neck. The filler neck's got a little anti-splashback valve on there. We have some valving inside of the tank that is going to feed up to our number 16 is going to be the fuel outlet valve. This is going to be the valve that would open up during an overpressurization event. Here's our fuel containment valve. This is going to be the one that's PCM controlled, that essentially opens up the pathway or the door to the canister and tank side. All right. Then we run into our canister. This is our canister right here, which goes up into this guy right here, which is number 10. This is the canister pump module. So again, this thing is using a vacuum pump module just like this, which tells me we have a vent solenoid in here, we have a fuel tank pressure sensor of some kind in here, and we have a vacuum pump. This then leads to some sort of air filtration device. And then on the other side of our canister here, we are running to the purge solenoid right here going into the intake manifold, okay? Also, number 9 right here is another fuel tank pressure sensor. So this thing is using dual pressure sensors as well, okay? Here's the codes. I'm not going to go through the codes. You guys can go through the codes. Screenshot this if you want. But I just want to bring up the fact that we have a majority of our codes as manufacturer specific. Be careful when you're using a generic scan tool, okay? Here's our wiring diagram. Standalone fuel tank pressure sensor, our purge VSV, our purge solenoid, fuel vapor containment valve. This would be our vent valve inside of our canister pump module. We have a motor in here, which I'm assuming to be our vacuum pump. There's probably a diode on here that's not drawn. And then we have another pressure sensor right here. Hybrids, they call it the auxiliary battery. Interesting. I guess I don't know if I've ever seen it called auxiliary battery. I've seen it as 12-volt battery, but I'm assuming the auxiliary to be the 12-volt battery at this point. Okay. Anyways, here's where it maybe gets confusing, but hopefully by the time I'm done going through this entire graph, it'll click and make sense, okay? So we're going to go through this step by step, just like we did on the other ones, okay? So here we go. Step A. Step A is going to be our stabilization period. We're going to be measuring atmospheric pressure, right? This line right here is atmospheric pressure. Again, we're looking at two different sensors here, canister pressure and fuel tank pressure sensor. Okay, this one's in the tank, this one is in our vacuum pump, okay? Now it is possible, I don't know if I completely agree with where this pit is starting, and maybe they just drew it out at atmospheric because that's where it happened to be, but in theory, a sealed tank could be under pressure or vacuum currently, okay? We have not opened that bypass valve yet, so there's no reason that that tank would not be under pressure or vacuum if it is sealed. Okay, keep that in mind. All right, from there, what do? Just like on a leak detection pump system, we draw this thing down to a 20,000th leak. Turn the leak detection pump on. With the vent open, we are measuring through that orifice. Beautiful, we know what that looks like, so what do? We open the vent solenoid up and we measure vacuum on our whole system. Now when I say whole system, I don't mean fuel tank and canister side. All I mean, and I should probably specify, not whole system. We measure vacuum on the canister side of the system. That probably makes more sense. So we're only measuring vacuum on the canister side of the system up to our door, up to that fuel vapor containment valve door, okay? So our vacuum pump turns on. All right, here's our canister. You know, our pump is mounted to the side. Vacuum pump turns on. We're only measuring vacuum on this half of the system. The tank is separated by a door over here that is being untouched right now, okay? Which is exactly why we see our fuel tank pressure not changing, right? We should not see a change in this. If we see a change in this at this point, we have a problem with our door, okay, with our fuel vapor management valve that is potentially leaking. All right, so we are able to draw vacuum on our canister side to a sufficient amount. So what do? We open up the purge solenoid with the vent and the pump still on. We should see a quick decay of vacuum back up to the 0 or atmospheric mark. At that point, what do? Just like the other systems, we shut the vent off, shut the purge off. So now purge is closed, vent is open, our system is venting, and we pull another 20,000th leak check. Wonderful. This right here is the same exact thing that's happening on our system that's on our Avalon, okay? Where it changes is where we get to this spot. Right here's another stabilization period for 5 seconds, and then what do? Our fuel vapor containment valve opens. This is that doorway separating the tank and the canister. This opens, okay? Now our tank and our canister is one complete unit. Our pump turns on, our vent closes. We are now drawing vacuum on the entire system from purge solenoid all the way back to gas cap, okay? We're measuring vacuum on the entire system. Both of our pressure sensors should respond, okay? So we're gonna pull vacuum on the entire system until we reach our threshold again according to the canister pressure side. At that point, we shut off the vent solenoid and we shut off the fuel vapor containment valve. At this point, guys, this is where we know we could potentially have a problem. At this point, we have a sealed in vacuum fuel tank. Our fuel tank should remain in vacuum no matter what the canister side does. Unless we have a change in temperature, volume, or volatility, our fuel tank will remain at that level of vacuum if it is a perfect seal. Now, in all reality, we will never fully maintain at that level. Like, they have a pretty straight drawn line here. This will never maintain perfectly, but our tank should hold vacuum, okay? If this starts to tick up or it follows exactly what's happening on our canister pressure side, we have an issue, okay? But now we are measuring and able to measure separately the fuel tank pressure side and the canister pressure side. So what do again? We run another 20,000th leak check because Toyota just loves doing it. So our canister side is the only thing being measured right now by our canister pressure sensor. And after that test passes, then we go back to atmospheric. If you see your fuel tank pressure sensor following your canister pressure exactly, if they are mirror images of each other, this door is not closing. Okay, this door would be hanging open. You would also most likely see that in this area over here. You would see your fuel tank pressure dip down at these points as well. Okay, so keep that in mind. The system is two halves that are separated by a door called the fuel vapor containment valve. If that door is leaking, you will have pressure sensors that look very similar. If that door is doing what it's supposed to, they should do different things. okay? Okay. One more thing, guys. I forgot, I wanted to show you, actually, I'll show you the Prius in just a second here. So what are some things to watch for on these closed systems? Well, the fuel vapor containment valve is closed. Your pressure readings should be different, which is what we just covered. With that door closed, you should have different pressure readings, tank side and canister side. When it's open, they should read the same because you're taking the system from two halves and making it into a single whole unit. Because the fuel tank is able to build a substantial amount of pressure before it's triggering its release, the fuel door release may be delayed. Now this is interesting. So these things have a fuel door that you got to push a button on inside of the car. I've never pushed a button and not had the door open. Apparently on these hybrid vehicles, that is a possibility to happen. All right, so you push a button, you might see a message up on the dash saying please wait, followed by refueling ready and the door popping open. This is because of that substantial amount of pressure that could be built inside of our fuel tank. What's happening at this point is the system is opening our fuel containment door, or our valve is being opened and allowing that pressure to bleed off into our vapor canister. Okay? So I don't know if you guys have run into this. If you have, I'd be curious to know if is it you have to wait 2 seconds, 10 seconds, a minute. How long does it take to bleed that pressure off? I suppose it would be dependent upon the amount of pressure in there. I'm sure that it's watching the pressure sensor and won't allow that fuel door to open until you're able to do that, because you don't want to be pulling the gas cap off with the system under a ton of pressure. Potentially could cause splashback or something. I mean, we do have some sort of valve in here that's to prevent that, but we just want to reduce the risk of any potential problems, okay? So before I get into the closing thoughts, guys, I just want to go over one more thing here. Let's get this out of the way. I want to show you guys underneath this Prius. Now, I know a while ago we talked about hybrids. We did a hybrid class or two. Jim Bates was actually here hanging out for some hybrid stuff. There's a lot of hesitation and questions around hybrids, and I just want to bring up, guys, that EVAP on a hybrid, while it might be a different system, it is not a high voltage system. You do not need to worry about the high voltage system if you are working on that vehicle. So I just wanted to show you really quickly what we got going on back here. Come on. There we go. All right, so join me under the car here, guys. Let's lock the camera in there. Let me go grab the flashlight. So as you guys can see under here, there's no big scary orange cables, nothing like that. You treat your EVAP system on these things just as you would any other EVAP system. Don't be afraid just because it's a hybrid. You know, we got a canister up here. We got some low voltage wires running to our fuel tank or canister pressure sensor and our vent and vacuum pump. We got a couple hose attachments on the canister, but nothing that is a huge deal to be scared about while working on a hybrid. Of course, whenever you're working on a hybrid, you want to make sure you are careful when you're hoisting the vehicle. You don't want to lift it anywhere other than intended. You don't want to go crushing those orange high voltage cables. But other than that, the EVAP system is an EVAP system. It's not high voltage. Don't worry about that when you get to these hybrids, okay? All right, let's see if you guys got any comments. Nothing else new. Okay, now guys, I want to give you the opportunity here. If you're watching and you had questions about something with the scan tool, something with the scope on this vehicle, something that you wanted to see while we're still here and all hooked up right now today, if there's something that you want to see that I didn't cover, speak now. I would be happy to show you or answer, whatever. Otherwise, I'm going to go into some closing thoughts here about Toyota EVAP, and then we'll call it a day. I'm going to give you guys a second here to see if there's any comments. All right, Keith, I think that was a good 2 inches of water on that one right there. Okay. I'll start on the first page and we'll check back in a second. All right, some closing thoughts for EVAP, guys. I just wanted to kind of summarize the 2 EVAP classes that we've had. Number 1, first and foremost, service information is your friend on these systems. Wiring diagrams, description of operation, code set criteria, all of that stuff is going to help you significantly when looking at these systems, because unfortunately Toyota wasn't nice enough to run a intrusive system from 97 to 2000 and a leak detection pump system from 02 to 09, or there's no specific year cutoffs for anything. So your best bet is to look at your service information, find description of operation, or look in a wiring diagram to determine what system you are working for or working with. Scan tool PIDs may not be written properly. You might be seeing PIDs in PSI or millimeters of HG when you're trying to measure in kPa. Just throw it in a conversion thing, just like we did. Just do a Google search, throw it in a converter like so. Super simple. Your scan tool may not control or display properly. We ran into that last class where our scan tool was telling us that the bypass solenoid was turned on, even though we proved that it was not with the scope. So just be careful. If something doesn't look right on the scan tool, please, please, please prove it out first. Scope, DVOM, test light, whatever you have at your disposal, prove out something before you go throwing a part at it, because it's possible that your scan tool is not telling you 100% of the truth, okay? Be careful. Some vehicles have replaceable components, some don't. You might have to replace just this assembly or the entire canister assembly, depends on the vehicle. Contact your parts department or give our catalog department a call if you have questions about your Toyota EVAP system. We would be happy to hook you up with the part number of our part for that. Okay, well, all these systems operate relatively similar. By building this base knowledge across all of these systems, you guys should be able to apply and diagnose any problem that comes up. If you understand how the system is being tested, you understand why the codes are being set, you should be able to apply it to just about anything. So even though you might not know exactly how a leak detection pump system works on a 2011 Prius, if you apply the knowledge that we have gained off of this Avalon, chances are you could throw a scope on it and you'll be able to figure it out just like that. All right, so that's why we grow this base knowledge at a system level. We could be up here all day doing case studies, but a case study is only specific to a certain vehicle, right? If we do a case study on an 06 Avalon, it's only specific to an Avalon with this motor, this system, this year, whatever. If we talk in a systems level approach like we're doing now, you guys are able to apply this to anything that is running that exact same style system, okay? It's good to have that base knowledge to adapt to other things. And lastly, guys, here, Toyota to date has been very good with sharing information, service information especially. Most of the charts and graphs on this presentation are from Toyota's service information. It's an excellent resource. Please use it to your advantage. You will not be disappointed. All right, last but not least, I put a little chart together for you guys. Copy and paste this, screenshot this, whatever you want to do. Throw it in a folder on your desktop. This is a quick cheat sheet when you are dealing with a specific system. I talk about how the system is leak tested for the 6 different systems we've covered, whether it's a comparative system, a purge seal system, or a key-off vacuum pump. Then we talk about what we're measuring with the bypass on or off, whether we're tank side, canister side, or full system. What your fuel tank pressure sensor should be reading with the key on, engine off. Remember, non-intrusive and intrusive, we're reading pressure, vacuum, and then these are all atmospheric. And then our hybrid system should read pressure and vacuum, but only on the fuel tank pressure sensor, not the canister sensor on this one. And then whether these systems are sealed or vented. Of course, the first 2 were sealed. Our key-off system, like this Avalon, was vented. And then our Prius systems bumped into that bladder deal where the bladder is sealed and the tank is vented. And again, our hybrid system, remember that our tank is going to be sealed on there and our canister itself is going to be vented. So just a quick little cheat sheet for you guys. Copy and paste it or screenshot it, whatever you want to do. But throw it in a folder on your desktop, because next time you get a Toyota problem in, you can refer back to this or come back to the video, guys. I've made a playlist out on our main Wells Vehicle Electronics channel that has all of our EVAP training in there for you guys, with everything labeled what we're talking about for that class. So instead of me shipping you guys all out a book about this class with all my information in it, you guys are able to just go back out and watch the video next time you have a Toyota in the shop. Let's see if we got any more comments. Jim said great information, great job, lots of info. Thanks, Jim, I appreciate it. Now guys, to close this up today, I have some important news for you guys for this 2 o'clock time zone class. EVAP 4 will be covered on September 7th. We are going to be going over a certain domestic EVAP system. I'm not going to give it away yet at this point, but we will be covering a domestic system. Now guys, moving on here from the from September 7th and on, we will only be live broadcasting out at the 11 o'clock Central Time, okay? If you guys are currently watching this live and this is your time slot, I'm sorry, but we are bumping everything over to the other channel as well as the 11 o'clock time. So if you're currently subscribed to the channel that is called Wells VE with the little gray logo, make sure to do a YouTube search for Wells Vehicle Electronics. We have a red logo on there. Make sure to subscribe to that channel. That channel is where we're going to be going out from here on out at 11 o'clock Central Time for our classes coming up, okay? Again, guys, I apologize if this was your main go-to class. It just, these are getting very long, and we're just going to bump down to one class for you guys, okay? Again, if you're not able to catch the 11 o'clock time live, you can always catch it as a recorded video afterwards. They're always published immediately after following the live event, and I will go out and answer the comments and questions just as I do live through the comments option of YouTube, okay? All right, I think that's going to be about it. If you guys have any more comments or questions, definitely go ahead, type them in the chat box below, or comment in on the video afterwards. I'd be happy to answer any questions that you may have. And if it's something that other people should know, I will bring it up in the Tech Connect episode that'll be coming up at the end of the month, where I will also be covering some of the fuel level information for those Prius Bladder systems, okay? So I think that's going to be about it for today, guys. I hope you enjoyed the class and know more now about Toyota EVAP systems than you ever possibly wanted to know. But we need to know the system basics, right? I mean, who would have thought that this vent solenoid would be located inside of this thing? Who knew about a 20,000th orifice inside this thing? It's a lot of things that could throw you for a loop. So, all right, that's going to be it, guys. Thanks for watching. I appreciate you being there and supporting us and the comments. It's good stuff. So check us out, social media, LinkedIn, Instagram, Facebook, and Twitter. The links for all those channels are down below, or just search for Wells Vehicle Electronics. If you guys liked what you saw today, please thumbs up, subscribe to the Wells Vehicle Electronics channel. And that's going to be it. So thanks again for being there. You guys have a great weekend and have a happy wrenching. All right. Thank you.